Okay, class, so we're going to start talking about characteristics of gases. So the first thing we're going to talk about is the kinetic theory, or better known as the kinetic molecular theory. So it states all matter is made up of particles in motion. Okay, and 5 key points that go along with that. Number 1, the particles in a gas are considered to be small, hard spheres with an insignificant volume. Number 2, the motion of particles in a gas is rapid, constant, and random. Number 3, collisions between gas particles and between particles and the container walls are elastic collisions. This is very important, elastic collisions. We're going to talk about this more in depth. Okay, and just quickly about elastic collisions. So during an elastic collision, kinetic energy is transferred without loss from one particle to another. And I'll put this down here. And the total KE, I'll just say, well, just write out kinetic energy remains constant. It's very important. Number 4, there are no forces of attraction or repulsion between gas particles. And number 5, the average kinetic energy of gas particles is dependent upon the temperature of the gas. So you could think of this. So if the temperature increases, and we'll talk about this a little bit later, if you increase the temperature, you're going to increase the kinetic energy. If you're decreasing the temperature, you're going to decrease the kinetic energy. Okay, so we see some pictures here, some diagrams of elastic collisions. Okay, and in these figures, these gases all share some general characteristics. So, if we look at part A here, the rapid constant motion of particles in a gas causes them to collide with one another and with the walls of the container, like we talked about in the previous slide. Figure B talks about the particles travel in straight line paths between collisions, and C, a gas fills all the available space in its container. We see this bromine vapor here. Okay, so we're going to talk about temperature. So temperature is a measure of the average kinetic energy of particles in matter. And just like we talked about two pages ago, if gases are heated, increases the kinetic energy, which means particles move faster and temperature heats up. If gases are cooled, the kinetic energy decreases. The particles move slower and the temperature goes down. We could think of that in terms of the 4 seasons in Pennsylvania. When it's warmer out, the temperature's higher, and people move around a lot more. In the winter, when it's cold, people will first the temperature goes down, and people tend to stay inside and not move as much. Okay, so we measured the temperature for gases in Kelvin, and here is the formula for Kelvin. K equals C plus 273.15. We're just going to use, when we do calculations later this unit, we're just going to use 273. And the coldest temperature that matter can reach, because all motion stops, is at 0 Kelvin.